So welcome to today's session of water and wastewater treatment. This is seventh week session, and I am Saptarshi Bose, here PMR research scholar from IIT Madras. So as usual, we will try to solve few numerical and theoretical questions. So the first question is conceptual. Which of the following determinations are necessary for the raw water from a lake to use as a source of supply for boiler feed? If you want to use that water for boiler feed, what characteristics should be there or what necessary check you should do. You can use the chat section for writing your answer as usual in message section. Maybe I will give one more minute, then I'll move on to the solution. Okay, Abdul is writing A and C. What about others? Okay, fine, we'll go for the solution. Right? So the correct answer is A, C, and D. Three. So we need to check for this turbidity. If there is some turbidity, it will spoil the boiler reactor. Also, we have to check about this hardness. If it is a very hard water, then what will happen? This will precipitate the calcium carbonate in the boiler reactor. Even you have seen this kind of this incident in your home while you were boiling some water in some utensil or any pot, and if that water is very hard, then you can find some precipitate at the bottom of the pot. So it will actually create some difficulties in the reactor. Also, it will damage the conducting pipes. It will precipitate there. so it will obstruct the flow. As well as we have to take care of the CO2 gas because this can also generate this carbonate and it can form the hardness. So the next one is a numerical type question. The population of a city in the year 2010 was 1 and 10 to the power 5, I guess, right? 1 lakh around that. And if the average increase in the population per decade is 35%, an estimated population of the city using the geometrical increase method you have to calculate for the year of 2030. So I have the data for 2010. The average increase in the population per decade is 35%, and I have to use this method, geometrical increase method. So please calculate as fast as possible. If you can remember the formula, use it. If you can't, you can go through the notes and use the formula. Maybe 1 more minute because this is very easy one. Okay, have
Yes,
to solve.
yes. You will said 2 minutes. Just two
Okay,
minutes. Yeah.
okay, fine, fine.
Sir, answer maybe 2.46 lakh.
One lakh
Two.
82,250.
Okay, thank you both, Ranjit and Ruchita. So we'll go check the answer. Okay, I'm getting this kind of answer. Please check. I might be wrong. That's what I'm saying every time. Please check numerically. So this is the formula for your
Same
geometric
answer.
answer. Okay, thank you. Thank you so much. So this is my predicted population at 2030, and this is my population which I have around 2010,
Okay.
right? So Pn here I am using this for how many number of decades we are going through to calculate. So here you can see it is 2 decades from 2010 to 2020 and from 2020 to 30. So two number of decades. So n will be 2. Here in case of R, I will write 35. That was 35% increase. And in case of P naught, you have to write this around 1 lakh, right? If you calculate, I am getting this around 182 and 250, right? So we'll move to the next question, theoretical question regarding microbes or microscopic organisms and their related health problems. Please match quickly and give the answer. Okay, I got the first answer from Abdul. He's saying C,
Uh,
right?
Sir, option A maybe.
Okay, Ranjit is saying A. So A and C I got. Anything else? Okay, so the correct answer is C, right? Not A. Here you can see the protozoa is related to dysentery. Then this bacteria is related to typhoid fever. Then nitrate is methemoglobinia, and then the virus we have that is for the hepatitis, right? So the next question is again theoretical or conceptual question regarding zeta potential or the energy barrier. Please go through the question. It is related to the theory of coagulation. And answer.
Sir, option A, ionic layer compression.
Thank you, Ranjit. So you are saying option A, ionic layer compression.
Option B.
Yeah. Thank you, Ruchita. You are saying option B. Okay, fine. So the correct answer is option A, not option B. This is the ionic layer compression. So in case of we can see this with coagulation, what happens? It will form some hydroxide and it will go beyond the solubility product. So it will go for the precipitation at the bottom, and during this time, it will take out whatever the colloids are present there with the flock. In case of interparticle bridging, what happens in case that case we use polymers. Metal usually we are now using polymers. Earlier days we used to use this metallic salt. So this will uh, actually it will create some bridging kind of thing with two different polymers, and it will take away the colloidal particles. So in case of ionic layer compression only, when two particles are there with different, I think you have seen this kind of picture. I am not properly drawing it, that's why. So if we want to compress this ionic layer around this particle, mostly the negative ionic layer, then we have to give the force, or we may need to increase the concentration of the particles so that it will come closer at the end and it will from this ionic layer compression, and it will like go beyond this zeta potential. It will exit that. So this is again a numerical question. This is the data. Please carefully write it down. Then we'll go to the question. Just write down what is the amount of ferrous sulfate added, that is 25 gram per meter cube in the sedimentation tank, and then also write down the alkalinity form used, like that use or reacts with the alkalinity. Write down the equation FeSO4 7H2O plus CaHCO3 whole 2, something like that. Please write it down, and then also in the next step write it down that a CaO is formed in calcium hydroxide, and then this lime actually is reacting with water to form this calcium hydroxide. Then again calcium hydroxide is reacting with ferric bicarbonate. Then it is producing the hydroxide form and also calcium carbonate. Please write down the molecular weight. If you know the molecular weight of each element, then there is no need to write it down. You already know. So I will go to the question. If you need, I'll again come back to this slide. So the first question is the minimum alkalinity required to react initially with ferrous sulfate that you have to calculate. What is the minimum alkalinity should be there to initially react with the ferrous sulfate in gram per meter cube as CaCO3. So be careful with this unit. You have to convert this as CaCO3. Minimum alkalinity required that will react with the ferrous sulfate in gram per meter cube as CaCO3.
Sir, kindly explain the answers.
Okay. Yes, I'll explain the answer. So anyone is trying to solve this? If you need some time, you can ask for the time. Or if you find this is very difficult, then I'll go for the solution. Just a minute. If you need 1 or 2 minutes, I can give. Otherwise, I'll go for the solution. Maybe 1 more minute, then I'll go for the solution. Okay, so we'll go for the solution. Right. So the molecular weight of FeSO4 H7H2O you have first have to calculate for ferrous sulfate, and the elemental molecular weight was given, that was 56, and S was 32 gram per mole, something like that, and you can calculate this. How to calculate the molecular weight? I think all of you are aware of that. So I'm not going to that details. So I'm getting 278 gram per mole. Now you have to convert this calcium bicarbonate to calcium carbonate. As calcium carbonate, you have to convert these units. So these also I also explained in the previous sessions many times, multiple times. So I am not going to explain this again. So how to calculate this? You have to go for the molecular formula, and then you have to go for the equivalent weight of calcium carbonate also. And from here, you can convert this as 100. So this is the calcium bicarbonate I am converting. Right? This is calcium bicarbonate as CaCO3 I am getting. Now I will go back to the equation. This was my equation, first equation, right? So here you can see this ferrous sulfate I have added in the reactor or the primary settling tank, and then it consumed the alkalinity. So alkalinity was in the form of calcium bicarbonate. So for 1 mole of ferrous sulfate, 1 mole of calcium bicarbonate was used, right? So that was the initial game for our settling tank. So here the same thing is written, same equation is written. For 1 mole, I am using 1 mole, right? So 1 mole of ferrous sulfate reacts with 1 mole of calcium bicarbonate. So required alkalinity, nothing. This is simple unitary method, right? So you have going through this unitary method from your class 5 or 6, something like that. So for one, I have for one ferrous sulfate, I'm taking 1 calcium bicarbonate for 25 gram of meter cube of ferrous sulfate. How many gram of meter cube of this calcium carbonate, sorry, calcium bicarbonate or the alkalinity I need. And already I have converted this calcium bicarbonate as CaCO3. So we no need to take care of, or we no need to think about this unit conversion, right? I have already converted this at 100 gram per meter cube as CaCO3, right? As CaCO3 is already there. So I no need to think about this, right? And this gram per meter cube, and here I am getting this gram per mole. So all those things are getting cancelled out. I am getting this 9 gram per meter cube as CaCO3. Or already it is written here, so it is not written, already written here. So this is the simple thing. For one for 25 gram per meter cube, how much? This is the thing. Now the second question is, it is a relative question. I hope now you can solve this. The amount of lime required as CaO to react with FeHCO3 whole 2, and it should be in gram per meter cube. Like, so the hint is this is for the next equation. There is another equation where I have added lime that formed that calcium hydroxide, and then it reacted with my FeHCO3 whole 2 and produced calcium carbonate. So what is the amount of lime you need to add in the settling tank? Maybe 2 or 3 minutes. Then just go through the equation and use your unitary method. Just convert wherever it is required. That's it. Okay, we will go for the solution because we have many questions today. So similarly, we need to solve this. You have to understand the equation, chemical reaction, and you have to calculate. So the required line as CaO we need to calculate, right? and it is based on the dose I have given. So the dose of ferrous sulfate was 25 gram per meter cube, right? So the molecular weight of FeHCO3 we have to calculate same way from the elemental molecular weight. You can convert it for the molecular weight of the compound, and I'm getting 178 gram per mole, right? And the molecular weight of CaO, that is lime, I'm getting as 56 gram per mole, right? Again, this is the equation is already given. Here you can see that from one lime I am getting one calcium hydroxide, right? From one lime I am getting one calcium hydroxide, and but there is a problem that for one FeHCO3 whole 2, I need two CaOH whole 2 calcium hydroxide, right? For 1 mole of FeCHO3 whole 2, I need 2 moles of calcium hydroxide. That is required. So that statement is written here. So you have to calculate accordingly. You have to basically you have to multiply it by 2, right? So here it is. Uh, I need to convert this for FeHCO3 1 mole, right? I need how much? 2 moles of CaOH whole 2, and for 2 moles of CaOH whole 2 I need 2 moles of CaO, right? So I need to multiply with 2, and the basic dose was 25 gram per meter cube. So I am here multiplying with here you can see that was 178 for this FeHCO3 whole 2, right? And also I have calculated in the previous question what is the molecular weight here for FeSO4 7H2, that was 278 gram per mole. So I am getting from the previous equation, you can see from 1 FeSO4 7H2O, that is ferrous sulfate, from 1 mole of ferrous sulfate I am getting 1 mole of ferrous bicarbonate, right? And that is why I am taking this for the unitary method, same thing for 178. For 278 I am getting 178, and then multiplied with 25 gram per meter cube. For 25 gram per meter cube, how many what is the amount of ferrous bicarbonate I am getting, and that is multiplied with 2 into 56, that is my CaO. For because for each ferrous bicarbonate I need 2, so that is why I multiplied by 256 divided by 178, I am getting 10.1 gram per meter cube. So this thing like the unitary method, you have to just calculate considering the molecular weight and the equation, the chemical reaction, how many moles you need and what is the molecular weight, and similarly you have to calculate for suppose 100 molecular weight, I need something for 200 molecular weight. So for 200 divided by 100, and for suppose 300, that is 200 divided by 100 multiplied by 300. This is the same molecular formula. For suppose for 100, that is the gram per mole, I need 200, 200. For 1 I need 200 divided by 100. For 300 I need multiplied by 300. That is the thing. Again, the following statements are associated with alum coagulation. Think carefully and write down your answer.
Sir, option D, 2 and 4.
Thank you, Ranjit. You are saying that option D, like 2 and 4. Okay, you can mute yourself. Yeah, thank you. So D, option D. Anyone else want to answer? Okay, so the right answer is option A. That is the decrease in the alkalinity of the treated water. It will consume the alkalinity, maybe in the form it was in the form of calcium bicarbonate, or then the formation of hydroxide flux of the alum. It will create the flock and it will take down all the colloidal particles from the water, and then it will change the pH of the treated water. So this is the thing, and it will not decrease the hardness because this is not related to the hardness removal, so it is not actually change the hardness. Then this is another question, another theoretical question. Bacteriological examination of drinking water for E. coliform is performed because similar question we have discussed in the previous sessions.
Option D, sir.
Thank you. Thank you. You are saying option D. Anyone else want to answer?
Option A.
Okay, you are saying option A. This is very easy one. So the correct option is option C. There is neither the pathogenic, it is not that much harmful bacteria. So this is not, and this will not say whether there is viral contamination. So D is cancelled, and this will indicate the organism, whatever the pathogens are present, which can cause harmful effect or disease, it can indicate them. So that's why we are indirectly checking their population during our test. So in the context of alum, the sweep coagulation is achieved when these conditions are there. So think about the sweep coagulation and answer. Okay, so the correct answer is B. Here you can see the coagulant dose is much more than what is required for the destabilization. Then it will sweep away all the colloids, right? If it is less than that, then it will not form the enough flux, so it will not happen. If this is enough, then also it will not act as the sweep coagulation. But if the flow dose is very high, then it will form bigger flux and it will sweep away all the colloidal particles with that. So the next one, okay. So this is my question. This one is a numerical question again related to the population growth. I assume that everyone can calculate this because you have tried the previous one and that was correct. The only thing is here you need to take care of this arithmetic rate of the population growth. That is my method here. Present population was this much, then expected population after 20 years, it was given as 52,000. Then present water consumption is 3,700 meter cube per day. Then water treatment plant design capacity is around 5,600 meter cube per day. You have to assume this arithmetic rate of the population growth. So the number of years from now when the plant will reach its design capacity. So you have to calculate this number of years. Maybe 1 minute or 2 minutes I will give.
This is 19.4, sir.
Thank you, Abdul. So we'll check 9.4. You said maybe 1 more minute, then I'll go for the solution.
9,000.
9, how much? Okay, you were saying 9, right?
9,000 meter cube per day.
No, no, the question was,
9,000, yes.
no. Question was you have to calculate the number of years, not the design capacity is already given, right? The design capacity is given. Okay, so we'll go for
Okay,
the solution.
okay,
No problem. No problem.
okay.
So the correct one is 19.40 years. I think Abdul said it correct. So this is how we have to solve this. The first thing is the arithmetic increase method. This is very easy formula. I think all of you know about this one. So Pn equals to P naught plus N multiplied by X bar. So this is the average increase in the population per year, that is X bar. And now you have to calculate what is the average increase in the population per year. Because it was given as the present population was given as 34,000 and after 20 years it was 52,000, right? So 52,000 minus 34,000 divided by 20 and I am getting as 900 per year. So this is per year the average increase, not per decade. So be careful with that. So here that's why we are not dividing with 2 but we are dividing with 20. So we need per year what is the increase in population. Then the design discharge to reach the maximum capacity. So these was the design capacity. This was the maximum design capacity, that was 5,600 meter cube per day, and present water consumption is around 3,700 meter cube per day. So what is the gap? So that is the maximum one. So it was the design capacity, and now I'm this is the for the present time, this 3,700. So what is the gap? What is the range we can increase? That is, I am getting 1,900 meter cube per day. So this is the range I can go. Maximum up to this range I can go. I can increase my design discharge or the discharge. Basically, the discharge we can increase. Uh, then the next step you have to calculate what is the present average water consumption per head per day. How you will calculate? So here, this is my present population. There is 34,000 and the present water consumption is 3,700 meter cube per day. So if you just divide this 3,700 with 34,000, this is my population, then you can calculate 0.1088 meter cube per head per day. This is the present average water consumption, right? So per person, so there was this much of person, this much of population was in that city, and this was a total consumption meter cube per day. If you divide this, you will get per head what is the water consumption. Then increase in the water consumption for each year.
Sorry, sir, your voice is echo.
Okay, let me check.
Unable to hear, sir,
Ah,
unable to hear.
okay,
Voice is in echo.
so now is it okay? Can you hear me properly? I think I can.
Yes, sir.
Okay. Ranjit, thank you. So, so every year I am getting this much of increase, 900 per year. So what is the increase in consumption of water per each year? Simply 900 per year multiplied by this is 0.1088 and I am getting 97.92 meter cube per day. That is increment of the water consumption. And another thing I am getting this. I think there is some issue. Okay. So yes, I need to calculate this for per year, right? So I think there is some issue. I need to check. There is some issue because it was in year, right? It is day. So you have to calculate this carefully. I think I have done some mistake here. Okay. I think this value is 101. If I'm not wrong. Please check this value while calculating. Please check this value because yes, this value you need to change a little bit, I guess. Just checked. Okay. So this much of capacity, I need I can go up to this much of capacity.
This is
19.
97.92 is
Yes, 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 right.
92.1088 into 900 is equal to
Yes, yes,
97.92 is.
yes, right. I checked that. So this is my design capacity. We can reach, that is 19 meter cube per day. And if you just divide this, that was my design capacity. And every time I am increasing this much of every day, sorry, every year I am increasing this much of, I'm getting this much of increase. So it will be in year. That's why there was some confusion. So it will be in year because this is in year, right? That was in year. That was there was some confusion. So if you just divide it 1900 divided by 97.92, you will get your desired years. So check this carefully because so 1900 how much I'm getting divided by 97.92. Yes. So I am getting 19.4 years. So answer is correct. I have mistakenly wrote this, so that's why there was some confusion. So it will be in per year, right? So because this 1900 persons or the population growth is per year, so I am counting this per year. So if you just divide this 1900 by 97.92, I am getting 19.4 years. So within around 20 years or 19.5 years, it will reach the maximum design capacity. So beyond that, we need to plan for another treatment facility, right? So after you can say after 19.5 years or say after 20 years, you should increase the design capacity or you need to go for another treatment plant, right? So the next one is regarding the fire demand of a city of 1.5 lakh population. You can use the formula of American Insurance Association, also known as National Board of Fire Underwriters formula. You can take the help of your notes to get the formula. Please calculate this fire demand. You have to calculate this fire demand in MLD.
See, it is not showing. Question is not showing.
Sorry,
Fire demand, what you are telling about that, but this is not showing. See,
sorry, I can't hear you properly. Can you write it down, your doubt or what you
it
are
now
saying?
it is showing.
Okay. Okay.
Is it 71.8, sir? MLD 71.8.
Yeah. Abdul, thank you. 71.8 you are saying. We'll check.
Please show the calculations.
Hmm. Yes, yes. So the formula we will use this is the empirical formula. This is the fire demand. Q equals to 4637 root P 1 minus 0.1 root P. So here Q is the amount of the water in liter per minute, and P is the population, right? So just you have to put the population here, but the population should be in thousands. So it was around 1.5 lakh, right? Please mute yourself. So the population was 1.5 lakh. If you convert it into thousand, so 1.5 lakh multiplied by 10 to the power 5, then divided by 1000. So yeah, I'm getting 150. So I'm writing 150. If you calculate, you will get it is around 49,835 liter per minute. And now you have to calculate this into MLT, million liter per day. I hope that all of you know about how to calculate from liter per minute to MLT. So the next one is again related to the population growth. The population of a town for 7 decades from 1941 to 2001 is given in the table. So you can see the table year 1941, 1951, 1961, and the corresponding population is given. If the water supply scheme must commence in 2006, we'll start that around 2006. It is required to estimate the population of 30 years from that year, that is 2036, right? By incremental increase method, you need to use this incremental increase method. What is the population of the town for the year of 2036? Maybe 2 minutes.
Sir, can you show me the answer of last question because there is network problem. I have not seen the answer.
Okay,
Uh,
I'll
uh,
I'll
so
I'll quickly go to that answer, or you can also go to the video, YouTube video, or the uploaded PPT.
just, yes, sir. Just wait, sir. Just wait.
Okay, no problem. This is an empirical formula. Just you have to put the value. That's it.
Is it okay? This is not Quisling formula.
But no, no, this one is the American Insurance Association formula. I already told you, right, which one you need to use.
Sir, tell me one thing. Population here I can use in lakhs.
No, you have to
150.
use it into thousands. So that's what I told. It was 1.5 lakhs, right? Multiplied by 10 to the
Yes.
power 5 divided by 1000. So it will be around 150. That in thousands. That's why I wrote this 150. That is the population.
So, okay. If any formula, if it is if it is asked for using the Quisling formula, there I can use population in
Yes, yes,
thousand only.
yes, 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 yes.
Okay.
So it was
If suppose
it depends upon this empirical formula, right? So it will be given which formula you need to use. So don't worry about that.
okay.
Sir, this type of question is asking in the final examination also.
Yeah,
So much of calculation we are facing.
you might be have to solve this kind of question. So it will be given there that which formula you need to use or which formula or the data. I think even all the molecular weight of the elements will be given there.
It is only multiple question asking in the final examination.
Yeah, but there might be some kind of numerical questions also. There will be MCQ type of answers. Like suppose the correct answer is 71 here, right? So the answer will be around four answers will be there or four choices will be there. Something 100, 71, 50 or 20 and 0, something like that. So you have to check which
Uh,
one is the correct.
Sir, can you tell me something that how many questions are asking for the calculation based question?
That I don't know actually. So I will ask the NPTEL team. They will prepare the question. So I can tell you in the next session, hopefully, but I'm not sure about what is the percentage.
Actually, we are facing so much of problem while dealing with such type of calculations.
Yes,
We
yes,
had
I can
passed my
understand.
20 years back.
Yes, I can understand. I can understand. So I will check with the NPTEL team because they will form the question paper. They will set what is the percentage. So if they say me, I will tell you, no problem.
Thank you, sir.
So the next question is again regarding this population calculation. Only the method is different. Maybe I'll give 2 minutes because the same type of questions I'm repeating, only the method is different. If you are trying to solve, then otherwise I'll go for the solution directly. Okay, I'll go for the solution. So this is the table you have to calculate because for incremental population method, you need to work hard a little bit regarding the other methods, right? So this is a little bit difficult one, or I'm not saying difficult, it will be little bit time consuming regarding the arithmetic method or the geometric method. So what I have to do, but this is very simple one. It's not difficult, just you have to calculate a little bit more. So this is the year and this is the corresponding population. It was given in the question. So what is the increment, right? So you will what need to do what is that is 43,673 minus 39,285. So if you just calculate what is the increase, then I am finding this around 4,388 was the increase for this 1 decade. For 10 years, I am getting this much of increment, right? So this is my increment. Similarly, you need to subtract 43,673 from 61,425. You are getting this much of increase or increment, right? It is around 17,000, 17,752. Similarly, you can calculate all the values of the increment. Done. Then you need to calculate what is the incremental increase here. So incremental increase is nothing but what is the difference between these two, right? So again, same thing, subtract 4,388 from 17,752, right? I'm getting as 13,364. If this value is less, in case of this one, the population decreased, right? So increase was no, not the population decrease, population is increasing, population is definitely increasing, but the increment was decreased, right? For this decade, there was much more increment, that is 17,000, around 17,000. In case of this decade, it is 61 to 71, 1961 to 1971. There was little bit decrease in the increment, not in the total population. Total population is increasing. You can see this is the total population. So total population is increasing, but the increment was decreased. That is why it is 16,000, and I'm getting in the negative value. So fine, no issue. You can get negative value also in case of incremental increase. Similarly, we will calculate this table. So now from the above table, you can also have to calculate what is the total. It was not calculated here, but you have to calculate that what is the total increment, the addition, the summation of these things, summation, and summation of this table also. What is the total summation? You will get here. What is the total here, right? And also you can calculate the total population. So the total increase in the population, if you just sum this table, you will get it is around 116515. It is a very big number, right? And then it is around 1,16,000. Sorry, 16,000. 1,16,000. So what is the average incremental value per decade? So this is the total increment. What is the average incremental value for per decade? So that will be divided by 6, right? So I 1, 2, 3, 4, 5, 6 decade. So I am getting it is around 19,000, right? 19,419. That is the average incremental value per decade. And then there is total incremental increase I'm getting from this value. This is around 29,092, and this was from this value. So this is my total incremental increase. Now again, and I have to calculate for per decade. Here it is 5. Calculate this is 5, 1, 2, 3, 4, and 5. So I'm dividing with 5 to get the average value. I'm getting around 5,880. Now the number of decades is around 3.5 decades, because it is now 20. It is now 2001, and there is 5 years also, and then this is 3, right? From 6 to 16, then 26 to 36, right? 6 to 16, then 26, then 36. So 3 decades here and 5 years extra, because the data is up to 2001. The treatment plant will start at 2006. I need to take care of these 5 years also. So 3.5 decades I am getting, right? So this is my formula for incremental increase method. Now you just have to put the values, nothing else. So P naught, what is my P naught? This is my 2001 data. It is around 1,55,800, right? And this AN is 3.5. Then I have calculated X bar. X bar is around 19,000. Then you have to put the value for N, and finally the Y bar value. This is the average incremental increase. If you just calculate, I'm getting around 2,69,583, right, as my final answer. And next question regarding MPT test or MPN test or MPN test. You have to calculate what is the MPN per 100 ml value. The table is given, the size of samples are given, the number of positive and negative tubes are given. So you have to find out what is the MPN value per 100 ml for this test, for this multiple fermentation test. Maybe 1 minute, then I'll go for the solution.
Is it 332?
Okay. Yes. Thank you, Abdul, for your
Yes.
answer. We'll check.
Okay, sir.
Yeah. Abdul, you were saying that 332. Yes, Abdul, you are correct. The answer is 332.
Okay, thank you, sir.
Ah, thank you, Abdul. So the MPN test formula, all of you are aware about this. If you don't know, just go through the notes of the lectures. You will find that MPN per 100 ml is calculated as the number of positive tube multiplied by 100, then root of ml of samples in the negative tubes multiplied by ml of samples in the all tube. So you use usually 5 tubes with the different sample size combinations. Here, 4 sample size combinations, and we will ferment this with the glucose or the food and the microorganisms bacteria present, and we'll find out how many are the from how many tubes I am getting the gas, how many tubes I am not getting the gas. So depending upon that, we confirm this number of positive and negative tubes. So the number of positive tubes is calculated as what was in the table. Number of positive 4 plus 2 plus 3 plus 0. I'm getting 9. An ml of samples of the negative tubes, that was here 1 multiplied by 1, then 3 multiplied by 0.1, that was the ml, then 2 multiplied by 0.01, and then 5 multiplied by this one. So if you calculate this, I'm getting as 1.325, and then ml of samples in the all tubes. It is very simple, 5 multiplied by 1, 5 multiplied by 0.1, because everything was totally was 5 multiplied by all the sample sizes, and I am getting as 5.555. Just put the values here. Number of positive tubes was 9. This value and this 5.55, you will get as around 332. So the next one, theoretical question regarding the treatment unit and the function. I'll answer this quickly.
So answer maybe B.
Ranjit, thank you. You are saying that B. Yes, so for the aeration, I'm getting to remove this color order and test for self-draining hardness, coagulation. I'm going for this colloidal dissolved metal bacteria and then filtration suspended matter. Then next one is the select the correct statements regarding the coagulation.
It is A.
Uh, Thank you, Abdul. You are saying that A, but there might be some more correct statements. Maybe, not sure.
Option C also.
Okay, you are saying option C.
Option B is also.
Okay, so option B, right? So the correct answer is not C, only B, D, and A. Because the first one is very simple, the D. The first will go for the coagulation. If there is no coagulation, then there will be no the flocculation. Floc will not form, right? So the first we need to add the coagulant and you need to do the coagulation. Then the floc will form and then this floc will sediment and then we'll go for the filtration. This one is a very easy one. Alum will decrease the pH and it will form the hydroxide floc. It was very much essential, but not the zeta potential increase, because if the zeta potential increasing, then there it will hinder the coagulation process. So what is the main backbone of our coagulation process? We need to reduce the zeta potential. So that is the basic theory. If the zeta potential is increasing, then it is of no use to use the alum, right? In the water treatment plant, the optimum time of the flocculation usually given as 10 minutes. So some basic question, conceptual questions. So what will happen if the time is increased?
Option C.
No, option B. Unfortunately, it will break up and defect the purpose of flocculation. If you are going beyond this optimum time of the flocculation, then this will like collide each other and it will increase the volume and it will break it down. So the last, I guess this is the last question. Select the correct statements regarding turbidity.
It is C and D, sir.
Right, Abdul, you are right. The right answer is C and T. The clay slit finely divided particles cause turbidity, and turbidity is measured the ability to scatter the light. So this is correct. This is not the maximum permissible limit. And in case of this turbidity increase, the disinfection efficiency of UV method reservoir, no, actually it will prevent, because it will the UV light will not be able to penetrate the water properly. So actually it will decrease to some extent. So thank you for joining today's session. Hope you enjoyed. So we'll meet the next session.
Thank you, sir.